Hello guys, welcome to Mobilemaths with Gamtry. Today we want to look at shear under geometrical constructions 8. Okay, so I've got a unit square here, ABC. So, or ABC. Okay, so if I want to shear this along the x-axis, it means I can have my all C there. These points, because they are on the invariant line, they will not be changing. Then if I go to A and B, I can shear them going this using a force F there. I can shear and they can move to points like these ones. Okay, like that. Okay, so I can have a diagram. Let me have a proper diagram here where I've got the shear, and we are saying points on the x-axis, which is the invariant line, are remaining the same. So these are points O image and C image, they are remaining the same, while the points above the x-axis move by an amount that is proportional to their distance from the x-axis. So if D is the point which I can say K1, and E is a point which I can say, this is a small letter K there, K plus 1, 1 there, we can find our matrix of shear as, let's have a hypothetical matrix which we'll be using A, B, C, D. Okay, and we'll take initial positions of our C, and then we'll see the image of our C, then we can calculate the values of A, B, C, D there. Okay, let's do that. So initially, so this is our shear matrix A, B, C, D, which is multiplying with our initial C positions was 1, 0. Okay, this was 1, 0, 1, 0. Let me show you. This is 1 there. Okay, 1 unit. So we have 1, 0. Okay, then if we do the image, we said this is not changing, so the image of C is remaining 1, 0. Okay, so we can do the row by matrix, row by column, then row by column, and multiply, and we'll get, if we do the row by column, we'll get our A as, and our A and C is 1, 0. Okay, then we can do the same for when we are now reflecting, when we are now shearing on the A point, where it's now moving to D. Okay, let's do the same using the same matrix A, B, C, D. Initially our A was 0, 1. It moved to a point which is now our image D1, which was now K1. Okay, K1 there. So if we do our row by column matrix, you find that our B and D there will become equal to K1. Okay, so at the end of the day, our shearing matrix H can become, which was in the form A, B, C, D, is equal to 1, 0, K1. Okay, so this is when we have our shear that is parallel to, this one is for parallel to x-axis. Okay, so it means when we have shearing that is parallel to y-axis, the shear matrix for y-axis is now 1K. We interchange the k's there. So this is for when our parallel, when we are shearing parallel to y-axis. Okay, so this is what we have. Let's have an example. Okay, I've got an example here where they are saying G is a transformation represented by the matrix A, in that one. Okay, so basically, if you remember, we said we have got our 1, 0, K1. You can see that these are similar when we have our x parallel to x there. So this is the K, this is the K. The everything there is the same. Okay. Now find the image of form 3 under G. What we do, we just simply multiply G and our image there. Let's do that. For A, I've got my 1, 0 minus 2, 1, multiplying by 4, 3. So it's like this one is an X value, Y value. You write it like that, then you multiply row by column, row by column. If I do row by column, I'll get what? Let's do that. If I do my row by column, I'll get 1 by 4, 1 by 4 plus minus 2 by 3. Then below 0 by 4 plus 1 by 3. Okay, so at the end of the day, I'll have my 4. I'll have 4 minus 6 and 0 plus 3. Okay, so the image is now minus 2, 3. Okay, so the image is, you can write the image is minus 2, 3. Okay, like that. Let's do for B. For B, we are given B as 4 minus 3. Okay, let's do it under G. B, we do the same. 1, 0 minus 2, 1. 4 minus 3. If you do the row by column, you will get 1 by 4. 1 by 4 plus minus 2 by minus 3 and 0 by 4 plus 1 by minus 3. Okay, then we'll get what? We'll get 4 plus 6 and minus 3 here. So at the end of the day, we get 10 and minus 3. So the image is 10 minus 3. Okay, let's go to the last question. The last question was saying describe completely the transformation G there. So what we do for our G to describe it completely, we said this is a shear. This is a shear matrix. This is a shear transformation. So first of all, we talk of it, the transformation being a shear matrix, shear transformation, sorry. Then we talk of the shear factor. So K there, the K value here is the shear factor. So you talk with the shear factor is minus 2. Then we also talk of the invariant line. So we can say is the shear above the x-axis, and our x-axis is the invariant line. So we talk of x-axis as the invariant line. Okay, so that's how we describe. Why do we say x-axis is the invariant line? What happens here is this. Let me show you. If you come here to the matrix that we had initially, these values there, they represent x values, and the second one, they represent y values. So from the previous derivation that we're doing, these values are not changing, 1 and 0. Where we are having a change is here. That's where you can tell that this is this is the invariant line. For example, if I was going to have it as let me rewrite it as 0 minus 2, 0, 1. Okay, this is the x values, and these are the y values. This one is not changing. It's not changing. So that's how you show that this is the invariant line. Then the other one that is changing, that's the invariant line. That's the where you are having your shear factor. Okay, otherwise let's meet in the next lesson. Bye bye guys.